To prevent overloading in circuits, fuses or circuit breakers are connected in a series along the supply line. Electric current is fed into a home by two wires called lines. About 110 to 120 volts are impressed on these lines at the power utility. That's as long as you're in the US. Overseas in Europe, they use 240 volts. They use that because they received electricity much later than we did in America, so they had more advances. Meanwhile, back here, it would have been too costly and troublesome to convert everything that had already come to 120 volts into the house and into a 240 volts. So it's just been kept at it's just been kept at 120 volts. These lines are very low in resistance and are connected to wall outlets in each room. The voltage is applied to appliances and other devices that are connected in parallel by plugs to these lines. As more devices are connected to the lines, more pathways are provided for the current. The additional pathways lower the combined resistance of the circuit, right? We saw that in the last lesson. As you add more and more resistors in parallel, then the overall resistance is going to decrease. Therefore, a greater amount of current occurs in the lines. Lines that carry more than a safe amount of current are said to be overloaded and may heat sufficiently to melt the insulation and start a fire. Not only that, but remember, current is the stuff that kills you. It's not the potential difference. It's not the voltage. It's not the 120 volts. It's the current that is flowing through. So if you have a circuit with many devices, many resistors added in parallel, and remember, you want your house wired in parallel, because if one plug stops working, hopefully no plugs stop working, because that means you have an electrical problem. But if one plug stops working, that doesn't mean an entire section of your house shuts down. Instead, it just means that one outlet isn't working, and you got to go in there and figure out what's going on safely. Or if you are unsure how to do it safely, please hire an electrician. Consider a line connected to a toaster that draws 8 amps, a heater that draws 10 amps, and a lamp that draws 2 amps. If the toaster is operating, the total line current is 8 amps. When the heater is also operating, the total current is 18 amps. Remember, current going into the junction has to equal the current going out of the junction. If you turn on the lamp, the current is going to increase to 20 amps. In practice, the lines in your home are not perfect conductors. With large current used to operate a vacuum cleaner, the connecting wires do warm up, but for most cases, the resistance in the lines can be neglected. So we keep turning on these appliances, and that's causing more and more current to flow through the lines. When is too much current happening? To prevent overloading in circuits, fuses or circuit breakers are connected in series along the supply line. The entire line current must pass through the fuse. This is also in your car. You have these tiny little fuses inside your fuse box. If you've ever had a radio go out, or a speaker stop working, or a sensor not working, first thing you want to check is your fuse. Did you connect too many phones to your outlet while charging? If so, you may have overloaded the circuit and caused too much current to flow. If too much current flows through, then the fuse itself will burn up. If the fuse is rated at 20 amps, it's going to pass up to 20 amps. Anything above 20 amps is going to melt the fuse ribbon, which blows out and breaks the circuit. So once that ribbon is melted and gone, there's now a gap, and it's no longer a closed circuit. So it shuts down anything on that circuit. Before a blown fuse is replaced, the cause of overloading should be determined and remedied. Insulation that separates the wires in a circuit can wear away and allow the wires to touch. This affected effectively shortens the path of the circuit and is called a short circuit. Short circuits have a dangerous amount of current because it bypasses the normal resistance inside of the circuit. Circuits may also be protected by circuit breakers, which is probably what you have in your house. Older houses will have fuses, but I think by now I would have to bet that most houses have switched to circuit breakers. And circuit breakers use magnets or bimetallic strips to open the switches. Utility companies use circuit breakers to protect their lines all the way back to the generating stations. Circuit breakers are used in modern buildings because they do not have to be replaced every time the circuit is open. So in the 40s, 50s, if you overloaded a circuit in your house, you had to find a fuse. If you got a basement or the fuse box is in a really inconvenient place, then you've got to go all the way there, probably in the dark because you don't have lights, because you don't have a working circuit. And then you had to actually change out a fuse. Now it's just a matter of finding your circuit breaker. Always know where your circuit breakers are. Anytime you move into a new place, find out where the circuit breakers are. Because if things aren't working, chances are you overloaded your circuit and you just need to flip it. So now you just go and it's that easy. If the circuit breaker gets tripped, you just flip it back after you have remedied the situation. The most common breaking of a circuit happens, at least for me in my house, involving the hairdryer. The hairdryer just pulls so much energy, uses so much energy. So if you have two high energy devices connected on the same circuit, then you could easily blow the circuit. In your bathroom, you've got protections for this. You got the little test button where you can reset it straight from the plug rather than going all the way out to your circuit breaker. Same idea. It's just there to protect the whatever's plugged into the circuit and to protect the wires and to protect your insulation from heating up and burning and causing fires. So, how can you prevent overloading in circuits?